Okay, so looking at this question, it's asking us to find the resultant force. Okay, so finding the resultant force acting on an object which is being pulled east with 4 newtons force and north with 6 newtons of force. So that's all the information we are given. We're not given a scale, we're not given anything like that, and it's asking us to find the resultant force. Now, because it's a force, it is a vector, which means it's got a size and a direction. So we need to find what is the size of the resultant force and which direction is it pulling in. So size up a little bit, and we'll try and work this out. So it's not giving me any scale or anything on this, so I can make up whatever scale I want to. Now, because we've got 6 and 4 newtons, I would say a sensible scale is 1 newton per centimetre. That's going to make it nice and easy when we're measuring this. So I'm going to write that. If you're coming up with your own scale, write how many newtons you've got per centimetre. It will help the examiner know what you're trying to do. So first off, I'm going to draw my first vector. I'm going to start here, and I first off got my force of 6 newtons pulling north. Okay, I've done it way too far. So sorry, I'll start down here. I've got a force of 6 newtons pulling up, so I'm going to draw my line 6 centimetres up. So that's 6 newtons pulling north, following my little compass. Right, then I've got a force of 4 newtons pulling east. Okay, so never eat shredded wheat, north, east. So I'm going to go 4 newtons to the east. Now normally you would have your force going that way, so I'm going to draw this one on. Now what's tempting to do to find the size of the force is to draw that into a triangle now, which would tell you the size of the force, but it would not give you the right direction. Okay, and we need the size and the direction. So what we need to do is turn this into a square. So what we're imagining is, rather than being pulled 6 newtons north and 4 newtons west east at the same time, being pulled 6 newtons north and then 4 newtons to the east. Okay, or the other way around. So 4 newtons to the east, from there. Okay, gets me to there. And I can complete that again on the other side, so I can go 6 newtons north from there, and we've got a little square going on. Okay, now our resultant force is going to be the diagonal going straight across this square here, so it's there. Right, now to find the size of that force, I'm using my scale, 1 newton per centimetre, and I'm going to measure the length of this force, and I'm going to say that is, the nearest millimetre, 7.2 centimetres. I'm going to times it by my 1 newton per centimetre. Obviously, because it's the same, because it's 1, I'm not going to have to do any actual maths. It's going to be 7.2 newtons. Okay, if that wasn't 1, you would have to work that out by timesing by, so if it was 2 newtons per centimetre, times it by 2, and so on. Now, as well as the size of the force, I'm wanting the direction. Now it doesn't tell me where to measure a direction from. Sometimes it might say from north, in which case I would measure this angle here. I'm going to just make it a bit easier for myself. I'm going to measure from the east. Okay, so from the horizontal. So from the horizontal, from the east, I'm measuring this angle here. Okay, so using my protractor, pop that on there, and I have got an angle of 57 degrees. So it's 7.2 newtons, 57 degrees from the horizontal, or from east. Let's put from H. Okay, so 57 degrees from the horizontal, so from east. There you go.